Welcome back, generals, to another Let's Fix Generals 0 Hour to make the best game ever. Okay, so last session we worked on something and we wanted to implement something. Where was it? This one. This. Yeah. Build enum or class or namespace from function arguments. Yeah. Okay, so basically we now have lists in functions and in variables. Yeah, okay, so let's see. Function index. So we're looking at this one here, function. Yeah, build enum or class or namespace from function arguments. From function arguments. Let's rename this to plural function arguments. Variable arguments. Yeah. Okay. So for function arguments. Yeah. Okay, so function dot what is it? Function dot. So we have these three here, right? So function. So we're looking at const std string type name type name function dot that, and that would be the first loop, and then we make another one, 2, 3, and then we will have this one and this one. Yeah. Okay, and in these loops we will find or function arguments. So basically function context here, deckel context, function deckel context, seator or detour. Function is seator or detour. Well, we don't do this. So it will be similar to this. So if is expected class looks into arguments, looks into templates. Maybe. Expected class. Shit. If the name is a function argument, then it can be either it can be either a class or an enum, right? Oof. Ah, shit. Shit. Maybe this function should be a is. Let's see. So if this matches a function, if this matches, if the name matches a function argument or a template argument, then it's not guaranteed to be a class because it could be an enumeration type, right? If it ends with class or struct, then there is a good probability that this is expected class. Ah, man. Name is templated. Has seator or detour. Is function argument. ends with class, C or S. Is known class. Is known class. Is expected class. So the static context name, it can also contain a namespace in there. So looking at this once more, has ctor or dtor. Can we hold on? Std out of range, ctor or dtor name. Static context name. This function argument. I think here I think these two conditions here are not quite correct, because this one is not ignoring the template arguments. No, if it's templated, we are already out here. But this one here, this one I think is wrong. Shouldn't we here get class name without context name? Const std string view class name, and then we say here class name that. Okay, so if it's in a function argument or if it's in a template argument, then it can be enum or class. Yeah. Enum or class. Is expected class. Is expected class. Where do we currently use this thing? Here is expected class. Is expected. So, well, it's called quite often, isn't it? Find or create class by name. Oh. Find or create class. Is expected class. Parent class in X. I wonder if we should build this also later. Because when we call find or create class by name, which happens when? Hold on. It happens here from function context, variable context, function arguments, and also here. So type info. This is this is before we have built quite a number of things here. All this. Oof. Oh man, this is such a headache. is such a headache. So I think that we should do this later. Same for the namespace. Actually, for the namespace, we could do it. Wait, is there any condition? No, for the namespace, we can do it immediately. That's fine. I think. Yeah. That's okay. Because there's only one possibility. It can only be another namespace, right? The parent. But here, this check, it's too early for this here. Oof. Yeah. Has context name, class name without context name, class is templated, is template class. Yeah. Oh boy. Yeah. Parent name. Name minus class name. Name minus class name. That's context name. In the class, class. Why don't we have here an std string deckel context name? We do have the same for variable, right? Variable deckel context name, yeah. Base name, deckel context, base name. So this is the full class name, including context name, base name, excluding context name, class name, excluding context name. the context name. ABC, this becomes say ABC becomes that. Context name, class name. Okay, then let's rename this also to base name. Base name. And then we go to namespace, and we also rename this to base name. Base name. Then here we say the full namespace name, including context name, namespaces, namespace, variable, class function, class, namespace. Here's also name, the full function name, including context name, class namespace, declared context name. Yeah. Say AAB becomes that. Okay, then let's also put here base name. Base name, the namespace name excluding context name. Let's put that information also here. And then we also put this here over here. Okay, let's search for this guy here, base name. Actually, let's do it for, yeah, actually, let's do it for class first, base name, base name here. So we can say if has context name, then we do m classes is parent name, find parent name, parent name. Base name, the context name is that. Okay. It has a named class index. Find. Parent name. This context name. Oh man. Context name. Context name. This is for variable. What about for function, for namespace? Find or create namespace. Here, base name. And here's a parent name. 0 plus. So Decker context name is also that. Parent name. Okay, so we have this at least saved here. How about we say parent name, std move parent name, base name, parent name, namespace index, yeah. Base name is name. Yeah. It's anonymous. Okay. I think this looks okay now. And in the class, oh man, it's so complicated. Context name, parent name. I would say we move this down here. And then we also move this here, std move. There we go. Is this legal? It's a const, hold on. Shouldn't be const then. There we go. Okay, and then I think we need to move this out. Yeah. We need to move this away. Minus this one. I think this can stay here actually. Yeah, and then yeah, so the parent. Poor man. Find or create class by name. If the parent, yeah, the parent can be either it's either a namespace or a class. Yeah. What do we do here? Name. IT parent class. So I think what we need to do is build class or namespace from class context. Have that as well. Yeah. But before we do that, yeah, before we call that, what order should this be in? Function arguments. Should this be done before the context or after? I think that it doesn't matter. It doesn't matter. It's not yet done to do implement. It does not matter, but yeah. No, it does not matter which order we build this, I think. Yeah. What does it? Context name, context. If we build it from context, then it's either a class or a namespace. If we build from arguments, template arguments, function arguments, then it's either a an enum or a class. Oof. Well, that means if it is man. Function context, from variable context, from class context. Man, so complicated. Is expected class. What do we do here? IT parent class index, child class index. I see. I think this should be done first. Yeah. I kind of like it though that it's embedded in here and it just runs on its own. But the problem is, by the time we create a class here early during like this function creation step, during the function creation step, we need to do this because we want to push the function indices here into this thingy, right? Or do we not? Wait, find or create class by name. So here, okay, here it's built. Yeah, we built the base class and stuff like that. Yeah, parse type info. This needs to be run first. be run first. Actually, hold on. Parse vtable. Okay, but by this time all the functions are already there. I don't think we need to move anything. I think this can perfectly stay here. Yeah, I think so. Because the function is long done. Yeah. So let me cycle one more through. Yeah, so this is done. This parse type info here. This is the last step after the functions are built. Yeah. So by then, all the function arguments and variable thingies are all done. No, then I think it's fine. The classes are not built before this point. Yeah. Let's we can double check this. Let's put a breakpoint here. So there should be no classes created by this point. We can actually put an assert as well then. Breakpoints F5. Watch this. Classes 0. Yeah, perfect. Okay, let's put an assert here. Assert m classes dot empty. Expects no function, expects no classes created before, expects no classes created before all functions and variables are processed, are read in. Expects no class created before all functions and variables are read in. Yeah. Let's put this comment here behind this. There we go. Okay. Okay, no, then we're good. We're good. Okay, I was worried that we maybe have to move this outside here, this stuff, but it's okay in here. We have all we need there. Good. So we can absolutely. So we should add another function here if it's in a template argument, and then is expected class. Template syntax. Yeah, we should change this. So so we can have an enum class, and we say it's known class. Where is this used, by the way? It's class or namespace. Yeah. We should probably also create is known enum named to enum index. Boer is known enum. Let's put it here at the bottom. Actually, what order do we have? We have namespaces, enums, classes. Namespace, enum, class. Okay, that's okay. My expectation is that in this function here, in this one, we should have a assert not is known enum. That's my expectation. The decal context name is not expected to be an enum, right? Yeah. Assert not is enum. And the variable, same thing. Not is variable is known enum. Put a space here. Okay. Boy. Okay, so I think oh man, it's so complicated. So is expected class, I would say we change into enum class type data type. So there can be data type. No, it's not a data type. It's context type. Context type. So it can be a namespace, enum, or class. Yeah. And then we say here get, actually, hold on. Context type. There are more. There can also be oh man. So there can be namespace or class, and then also enum or class, right? Let's put this here, and let's put this here. Enum or class, namespace or class, enum, context type. Okay. So how about we create a function that says context type get best get context type get context type. Yeah, get context type. Good. Then we have this. Then we do const is expected class, and we put here a new function. And so what we do is we have MachOCodeGen do this, and so we do all these things here. So if it is a templated type, templated name, get context type, then this is a class, right? So we do context type class, right? If it has a constructor or detour, then it's also a class, right? If it is a function argument, then it is a enum or class, right? One of these two. Actually, hold on. This is not entirely true. This function argument. No, it is true. It is true. Or is it? Hold on. If it is a function argument, what if the function argument has a context? Well, the enum can have a context and the class can have a context. Yeah. No, I think if it is a function argument, it's an enum or a class. Someone correct me if I'm wrong. Yeah. Okay, and then so is function argument. So we should have another function now. We call this is template argument name. Is function argument is template argument. And then we create here if is template argument name. Then it's also an enum class. Expensive type is used as template argument. Yeah. And then we say, but if it is one of these two. Okay, but here we have an or. Then I think I would prefer these checks before this, because basically an or should be the last resort, right? That we say this or that. We want to be certain. So if it ends with class or struct, then it's templated. By the way, is templated. By the way, is this correct here? Is templated? Or do we need to do it here with this one? Get class name without context name. Oof. Get class name. Get class name without context name. Get class name. Get class name without context name. Yeah. It's templated. It's templated. So what if the context is templated? If the context is templated, then we know it's not a namespace. Yeah. We know it's not a namespace. Get class name without context name. It's templated. I think that we should pass class name here. And then we should also have a const std string view context name is context name class name name dot size larger than class name dot size, then otherwise this class name or name, and then here is name dot sub str 0 and name dot size minus class name dot size minus 2. Oof. Variable name without context name. Didn't we do this somewhere else here as well? Sub str. Already did it here. Context name. And here. let's put here a new function, static std string view get context name. So we are looking at std string view name with context, std string view name without context, and then there will be return. Let's do assert that name with context is larger than that, and then return name with context sub str. Actually, we can just return std string view name with context, and then name with context minus, wait, this assert actually should be name with context is larger than this. Larger than this, -2. Larger than that, yeah, -2. Okay, so then here we say name dot size minus name without context dot size -2. There we go. Huh? Why is this breaking apart? Return. Somehow things don't look the way I expect them to look. Maybe dot data. There we go. Okay, I think this is correct now. Get context name. Okay. Thank you. Okay, let's search for this here. So my expectation is that when we can call here get context name, so this is variable name and variable base name. Okay, I think this is a little bit cleaner, isn't it? Get context name. This one is parent. This one we can keep, and here we can also parent name get context name name and class name class name. There we go. Why is this complaining? Oh, it's returning a string view. Parent name. But that should be okay. What's the problem here? Why is this complaining? String view to std string. Huh? What? What is that bullshit? Huh? Context name. Get context name class name. Okay. What much simpler. Yeah, I don't know why this one thing is erroring. Can it not implicitly convert to string? I don't understand. Does it have to be explicitly here std string like that? Huh. That's weird. But maybe that's on purpose. I don't know. Okay, well then, but then there's a simpler method, just like that, right? Yeah. Okay. So we have class name and we have context name. Class name, context name is template. A class name, then it's a class. If it has a constructor or destructor, then it is a class. Okay, if it ends, if the class name ends here, ends with class or with struct, then it's also a class. Let's move it down here behind this one. I think this one takes precedence. This one, if it begins with a C or S, then yeah. Yeah, maybe. Yeah, it's template argument. How about we move this into another function because it's a bit unholy to look at. Let's call it has to detour. Let's do a bool is typical class name. Yeah, is typical class name. Class, and I think we just give it string view. Class name. By the way, this one, does it need to be a context name? I think this one we can also give a string view here. String view class name. Class name, there we go. Okay, so is typical class name, this can be a static. Is typical class name. And then put that here. There. Da. Okay, and then we move these guys. Move these guys in here. It's typical class name. Return false. Class name. Then we remove this one. Class name, class ends, class begins, blah 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 blah. It's typical class name. So then we say here, if is typical class name Oh, sorry, we are going here. Yeah. So we comment out this one here. Let's put this comment here. see my class as my struct are considered classes. Okay, and then if is typical class name return context type class. Yeah, and then we hope that this is all good. Okay, so if it is a function argument or is template argument, then it's enum or class. And then if is templated context name, if the context name is templated, then that means it must also be an enum or a class, because a namespace cannot be inside a templated class, right? So that would also mean context enum or class, and it's cheap check, so we put it before the other two. Class has context has template syntax. Yeah, it's typical class name. Enum or class. Okay, and if all fails, then we say, okay, you know what? Let it be a namespace. Yeah. Actually, hold on. Then it's namespace or class, right? It's never a namespace. And it's also never an enum. Oh boy. So there is no enum and no namespace. It's only... oh boy. Is there a way that we can know it is an enum for sure? I don't think so, because the enum doesn't have any interesting things. Well, it could be called enum. There could be enum in the name, I guess. Like, is there such a thing? Like, what happens if we search for enum? Enum. Here, look, there are enum. Yeah. Okay, so if a type ends, yeah. Yeah. So if the type ends on an enum, then it is an enum. Yeah. Sure. Why not? That's good. That's good. Is typical class name is typical class name. Then let's create is typical enum name. Is typical enum name. enum name. Man, we are going real scientific here on this shit. I want to get the best guesses. Yeah. Boy. Okay, so is a typical enum name if it ends with enum, right? Then that's that. And if it starts with E, let's say, and if then is upper, if the next is an upper, yeah. By the way, why do we have here two? There's only one needed. So then the next needs to be an upper, and then we need some lower cases. Then it's also an enumeration. And maybe we can also have a function for is typical namespace name. Is typical namespace name, which would be all lowercase, right? Namespace name. So basically, bool is typical namespace name. Namespace name, and then basically, if it's all lowercase, it's C++ lowercase string check lowercase string. I'll check all lowercase. This is very expensive here. That's a stupid approach. Don't do this. Because the problem here with this implementation is it has to check every character against this list. And that's not how you should do it. You should check in ASCII. You can simply check against ranges, like A to Z is one range, and 0 to 9 is another range. So it's just two ifs. Well, yeah, two ifs with 4 conditions total, right? Which is much cheaper than doing this thing. Yeah. All right. Okay. Jesus, reject pattern. Is upper, is lower, is lower. Is there a function that we can use to check if a string is lower or upper? C++ check lowercase. Oh man, maybe we need to ask ChatGPT. Is there a C++ std function that can check if a string is all lowercase? What does it say? Is all lowercase? Is the all of begin end? Why unsigned char? Is lower takes unsigned? What is that? Oh, this one? It takes integer. It takes integer. I don't know why it's taking unsigned char. That's wild. Okay, but all off. Okay, that's not too bad actually. This implementation. Yeah. How about we put that up here for now? Yeah. Static is lowercase. Well, is lower. And we make a std string view, str, all of begin end, and then we should take char. Because this takes integer, it's also sign. I think we should just do this all off. Okay, I like this. This looks nice. Where are we? We are here somewhere. Here is lower. So basically we want to say if namespace name if is lower namespace name, then return return this. Done. Return is lower. If it's all lowercase, it's a typical namespace name, right? Yeah, I think that's done. Maybe, I mean, this one reads a bit complicated, but maybe we say here C awesome. C awesome. Okay. Here awesome class. Here's E awesome. Yeah. And here is awesome enum. Yeah, just to clarify what this does. Yeah. Yeah. Okay. Maybe put the comment here so it doesn't waste too much space. Yeah. There we go. Okay. There we go. All right. Okay. Super pretty. Okay, so it's typical. Let's say this is std. Well, RTL. Yeah, std is lower space. Yeah. Good. Then we say, yeah. So we say if is typical enum name. We say class name as well, right? It should be okay. Class. Yeah, I think so. Class name, probably okay. Return context type enum. And then if is typical namespace name, then class name, return context type namespace. Okay. Otherwise, it's templated, then it's enum class, namespace or class otherwise. Well, hold on. If it is templated context, if it is namespace or class. What if it down here? Hold on. Get context type. Context type. Context name. By the way, this is wrong here. Basically, so right now we assert. I think what we should do is if it is larger, then we return this. Otherwise, what the hell? Otherwise, return empty string view, right? Huh? What is happening here? Oh, there we go. Get context name. Yeah. Return that, yeah. Why does this work? This one is a string, and we can assign this thing. Why was this not possible here? I don't understand. Why was this not possible here then? Why is this complaining? We're doing the same thing. We're assigning a string view to a string. Why is this not working here? Huh? What the hell? How about we create another function, static bool, has context name. Name with context, name without context. And then we say return this has context name. If has context name, name with context, name without context. Actually, has context name. Yeah. Name with context, name without context. Yeah. Has context name. Then we can simplify this to has context name, and then put these guys in there. Then we can remove this here. Okay. And then here we can do the same. Has context name, name, and class name. Okay. Okay, well, I still don't understand why this is complaining. That makes no sense. We give it a name. Why is it complaining here but not in the other place? I don't understand. It should be complaining about this one as well then. No? Okay, let's leave it there for now. Let's see what the compiler says. Yeah. Okay, so is templated. Is templated context name. This one will be empty. What happens then? Yeah, it will be. Yeah, won't find this. Context name. Context has template syntax. Enum class. Context has template syntax. So if none of these things are true, doesn't that mean that it's either a namespace or enum or class? Namespace or class. Huh. Context type. I wonder if we should turn it into flags. Because it's getting a bit wild. Context type, flags. Enum, context type, flags. Var type. Context type flags. Context type flags. None. None. 0. Okay, so namespace is bit. Oh no, we don't have bit 1. We have a 1, 0. Enum 1, 1. And 1, 2, and that will give us now combinations up to 9, and then we say here context type flags class context type flags. Maybe get context type flags. Maybe I should say context type flags. Using context type flags equals uint 8t. And 8t types flags and var type. You know, I should probably also have here var type. Using the var type uint 8t. Oh my gosh. 8t. Why don't we move this up here like that, and then we say this bar type. I think that's much better. Then here we say context type flex. Okay. Okay, context type flags, and then here on the function get context type. All right, context type flags, return. What is it complaining about? Context type flags class. There we go. Okay, so this one is also class. This one is enum. This one is namespace. And so here, this one is enum or class. Enum and class. And the same here. And here. And here. Namespace or class. So I do wonder, should this be like all three? Like namespace or enum or class. Could that be? Could be all three, right? If none of the other checks are true. By the way, we can remove this garbage here. Okay, so we have a bunch of checks. Class name. So we get the class name without a context name. We get the context name. Is templated class name. Then it's a class, yeah. If it has a constructor, it's also a class. If it is a typical class name, it's a class. If a typical enum name is an enum, typical namespace name is a namespace. But this could be a little bit of a false positive haven here. Because what if there are classes that are all lowercase, right? So we need to check this. We need to put some breakpoints in here, maybe also here. Yeah. So if the context name is templated, then we know it must be an enum or class. Yeah. If it is in function argument, then it also must be in a class, yeah. If it is template argument, then it must be an enum or class. Yeah. Okay, and if none of these are true, then it must be a namespace or enum or class. Are there any isn't there a scenario where we can exclude that this is an enum? We should probably also check what the parent is. Right? So if the parent, if we have a definition for the parent, yeah, that is another type of information. So if we know that the parent is if the parent is a class, then it can't be a namespace. Yeah. If it is a namespace, then it can be all three. But if it is a class, yeah, parent, yeah. If parent is class, Parent is class. Yeah. So here if is known class context name, right? Then why is this complaining? Oh boy. Ugh. Because it uses here lookup. Well, then we need to allocate a string. std string context name str context name. Yo, this is complaining here as well. No suitable user-defined conversion from const string view. Is that because it's const? No. So it's somehow, I don't understand why it doesn't like assign it. If it is a string view, it should be perfectly possible to assign it. I don't understand. Okay, well then we create a new one. Const. We allocate a string for the context. And then, so if it is a known class, then it can't be a namespace. Then it is either an enum or a class, right? This is a cheap check, so we should probably put it above here. Context is a class, and yeah, context is a class. But that also means that then this one can't be true. This can't be before this one. Yeah, so that means this check here hold on. Yeah, I think this check is too early here. This needs to be way down. This needs to be at the very end, I think. Yeah, I think so. Typical enum name is templated. Enum or class, namespace. Sure, let's put a breakpoint here. Oh boy. Oh boy. Now, this was a context name. Why? Like here, I don't understand. Here, it allows us to assign the string view to a string, but then on the other case, not. Let's see what happens when we compile this. There should be 2 compile errors, not 1. But there's only 1. Why is this allowed here? How is this possible? If the other one is not, that makes no sense. Like if this is not allowed, here, this one, then so it shouldn't be the other way, the other place. That makes no sense. What is this doing? Why is this acceptable here? Cannot convert. garbage. So this one wants us to initialize it like this. Maybe it's only constructing it fresh. Maybe assigning is okay, but constructing is, maybe that's why. Yeah. Ah, I see. Yeah, I see. So this one is constructing. The other one is just assigning, operator equal. I see. Okay, well, that's retarded. I don't like it. I think that's stupid. Okay, so must be, this needs to be last. This template argument is typical enum name. Yeah. Okay, this one really requires really good thinking here. Oh, because like the order matters. The order matters, yeah. Okay, let's walk through it once more. So if it is templated, we certainly know it's a class. Perfect. Okay, if it has a constructor or a destructor, also perfect. We know. If it is a typical class name, I mean, it's not definite proof that this is a class, but it's probably good enough. Let's say. Same with the enum. Right? Because if the name ends with enum, it's a pretty good indicator, right? Or if it begins with the E prefix and then the uppercase letter and then some lowercase behind that. So yeah, we should probably put some breakpoints in here to see how that looks. So, but yeah, these are a bit of question marks. Like they could also maybe be lower priority. I don't know. Actually, but maybe they are fine where they are, because we want to have specific results, right? It's better if you get like a shady result, and yeah, typical enum name. Okay, so is templated. Yeah. Class, yeah. So if the context is templated, then it must be an enum or a class. Yeah. If the parent, the context name, is a known class, then it also must be an enum or a class. If it is a function argument, then it also must be an enum or class. If it's a template argument, also. Yeah. Otherwise, we say if it is a typical namespace name, then we classify it as namespace. Otherwise, we classify it as class. Typical namespace name. Otherwise, it's either... Yeah, so the last is, if none of these conditions true, then it can be either namespace, enum, or class, right? Because you can't determine it. Yeah, I think that's fair. Yeah. Yeah. Class. But it looks promising, yeah. Okay, let's save all files. Poof. What's the time? Yeah, we are approaching 2 hours. I think it's time for a break. I think we got a lot of stuff done, but I'm a bit worried now because we're changing so many things right now and adding so many things. Like, I didn't test enough. Like, there could be a lot of errors now. So I'm a bit worried about the state. So we really need to have a good look once things are running and see like, okay, what looks wrong. Eyeball it, yeah. There could be errors somewhere. It's easy to make a logical mistake here. Yeah, there's a bit of guesswork here. Maybe we should comment this. Not 100% proof. Not 100%. Not 100%. But good enough. Not 100%, but good enough. Not 100%, but good enough. Not 100%, but good enough. Yeah. Context. So the context can be either a class or a namespace. What if it's a namespace? The context. Yeah, then it can be all three things. Yeah, namespace can be a namespace, enum, and class too. Yeah, okay. Yeah, so it's only this, because a namespace can have been a class. Yeah. Oh boy. Oh boy. Good. Okay, then we also need to like get rid of this thing basically. Let's already comment this out. Where is it? Here is expected class. That one needs to go. Sorry, but it needs to go. All right, there we go. Good. And then we need to replace it. Okay, but we can do that next session. Yeah. Good. I will take a break here. Then I hope you enjoyed. I wish you a great day or night. Until next time. Goodbye.